Hello, I am Exp10 from AML department. I am going to explain about the program implementation using k-means clustering for customer segmentation. Understanding clustering, objectives, implementation and applications. The contents of the program is objectives, implementation, execution and results and applications. First, objectives. Objective of the program. The objective of the program is to perform the customer segmentation using k-means clustering on a data set of small customers. By grouping customers based on their income and spending income, etc., we can better understand the customer behavior and identify different types of customer segments. We can assist in targeted marketing strategies and enhancing customer experience. Next, program implementation. Program implementation is divided into several main types. First one, importing libraries and loading data. Next, second, data exploration. Third, k-means clustering with elbow method. Fourth, clustering with optimal cluster count. Fifth, segmentation of data by cluster. Sixth, visualization of cluster. Importing libraries and loading data. Import pandas as PD and import matplotlib.py plot as plt are used in the necessary libraries for data handling and visualization. The dataset is loaded using pd.readcsv malcustomer.csv, which reads in a CSV file containing customer data such as age, gender, annual income, etc. Next, data exploration. Data.head displays the first few rows of the data set, giving a giving first few rows of the data set, giving a quick overview of the structure. Next, data.info provides the details of the each column data type and non-null counts are missing, that is the missing numbers. Data.isNull of sum checks the missing values in each column, ensuring data quality before proceeding with clustering. Next, k-means clustering with elbow method. To determine the optimal number of clusters, we use elbow method. This technique involves running k-means clustering for various cluster numbers and calculating the within the cluster sum of squares for each run. In each iteration of a for loop, we create a k-means model with n clusters, where it varies from 1 to 10. Fit the model to the data set, specifically selecting columns relating to spending behavior and income. Calculate the WCSS and measure of cluster compactness and store it in WCC list. Finally, we plot the WCSS values for each cluster to count to visualize the elbow, where the rate of WCSS reduction slows. This point typically indicates the ideal number of clusters. Here it suggests using 5 clusters. Next, third one, clustering with optimal cluster count. We rerun the k-means algorithm with n cluster equal to 5, the optimal number from the elbow method. After fitting the model, we predict each data points cluster using km.predict. The resulting cluster labels are added to the data set as the new column. Data of cluster equal to yPredict allow us to group customers based on their assigned clusters. Next, segmentation of data by cluster. The data set is divided into 5 separate data frames, DF0 to DF4, each representing a distinct cluster of customers. Each data frame includes customers grouped by similar income and spending behavior. Next, visualization of clusters. To visualize the customer segments, we create a scatter plot where annual income is plotted on the x-axis and spending core is on the y-axis. Each cluster is pointed in different color, allowing for easy identification of customer segments. A legend identifies each cluster with corresponding colors. The plot titled Customer Segments provide a clear visualization of the clustered customer segments based off income and spending. Next, execution and results. Third one, execution and results. Execution results. When the program is executed, the elbow plot reveals an elbow at 5 clusters, confirming that 5 clusters best balance compactness and separation. The cluster plot when visualizes these clusters, highlighting groups of customers with similar income, spending goals, and spending scores, representing distinct types of small customers. Each group can be interpreted as the unique segment, providing insights for strategic decision making. Fourth one, applications of clustering. Uh, Clustering has numerous practical applications across the industries. First one, retail and marketing. Customer segmentation helps in creating targeted marketing strategies by identifying groups with similar spending behavior. Next, banking and finance. Clustering aids in risk assessment by segmenting customers based on financial profiles, which can improve loan approval process and credit scoring. Next, healthcare. Clustering patients based on their symptoms or medical history enables tailored treatments and enhance patient care. E-commerce. Clustering customers' behavior helps recommend products and personalize shopping experience. Thank you. Now we are going to run the program in the Jupyter notebook. First, import pandas SPD, import matplotlib and load the data set. Next, going to find the head for few rows. Next, information about the data set. Next, missing values. Next, using the k-means, we are going to find the WCSS. Plot the graph in elbow method. We get the graph in elbow shape. Next, y prediction. This is the predicted values for the data set. Next, for each head we are going to find the different heads. Now we are going to visualize the data set using the scatter plot. Here is the different types of plots, so like cluster 0 to cluster 4 in different colors as black, red, pink, green, red, etc. This gives a overall customer segment using k-means clustering. Thank you.